We'll stamp it while you take relevant material from the whiteboard and while I go pee. It's just study goals. Anybody remember which ones?
30 through 41. 30 to 41.
30 to 41, Sam.
I have, yeah. That's good. Oh my god, we had to practice this.
Oh my god.
You got the job!
That would be a point that Mr. Gannon gave us that was like, oh, when he misled us. Because I had initiative to go again. I actually thought I did really bad things and all this stuff. I mean, I thought it was really hard. It was I was like dying and like right when I was dying and I just like it actually felt as a whole here.
It was so
You're feeling really having moral or ethical. Oh, wait. I think there's a lot out there, but we curve to the lowest dirt floor. Yeah, dude. So, like, are you saying the ATG?
You know what passive mind drainage is? One second. Sorry.
Jose, do the drawings go for study goal?
They do. They're for 15 mostly.
They're for what? Should I just write loud? No, there's it wasn't. Usually it isn't.
I just read about
You didn't do anything. He has it like hello.
you can't.
My brain now. You won't read my thoughts anymore.
Jay, did you see Hillary Clinton's video that she running? Did you like it? Really?
I think she sets the right pitch. I think this is going to be the most boring political campaign in history.
Well, no one, I mean, like, we already know.
Not just in the primary. I think, I am so ready to be bored by this election cycle.
But what if it's Bush versus Clinton again? Would that be interesting?
There's no contest.
Yeah.
Oh, I was like,
Not George. But, I mean,
I kind of feel like that's basically guaranteed before the dynasties.
Rand Paul, like, it's not going well for him so far. Like, he just didn't work out.
He's not a viable candidate.
He flip-flops.
And then Ted Cruz is obviously psycho.
Well, aren't they all? I mean,
I try to see the reason it goes.
yeah.
And he may not be psycho, he's just very extreme.
Yeah.
Okay, children, a couple of different things to do quickly. So Jake Cranberg is absent, huh?
Yep.
I'm glad I noticed that weirdness. Okay. One thing I wanted to point out is Post Lab is due Wednesday. Also, I've been building this list. I erased and cleaned up the board a little bit. So I wanted to just get all this vocab clustered in one spot. This unit has a lot of vocab that gets tacked on to this study goal or that conversation. And I'm not sure that I've been really attentive about pointing those out in all of my periods so far. So I just clustered all the vocab right here so we can kind of try to keep up with it. Also, I think period 2 may be the furthest along, but I'm not exactly sure where we left off. And I'm sorry to say that today I have sort of a lot of lecturing to do. Before I get into that, anybody have anything to discuss about the weekend? Is there anything we need to... Yes?
I didn't take the lab. Should have taken it last
No. I guess you would just get data from somebody else and hopefully they can talk to you about the post-lab questions. Anybody else? What?
what is that? Does it say diversion and recovery? Like on the logo?
Yeah. Yeah. All right. So, were we talking about strategic metals in this class? So remember, strategic metals, you can, politics makes strange bedfellows. You know that we have strange strategic relationships with countries that provide us with energy resources. You know that Russia has a whole bunch of countries in a headlock because they're the big supplier of energy in their part of the world. You know that some Middle East countries have unusual political leverage because they provide strategic resources like petroleum. Did I mention to you some of the weird countries that have surprisingly good economies because they have one rare metal to sell? Like Kyrgyzstan and Australia and New Caledonia and Jamaica. But there's one interesting example. Please look up. These have been, for the United States, the most strategic metals historically. But now that we're getting into electronics as a bigger and bigger part of our economy, these have become really important. I think this one and I was hoping I would recognize it, but I'm not. Maybe this one, but that's not. And there was another one. This one and this one, but there's probably others. There's a few what we call, please look up, rare earth elements or rare earth metals. James Bell, put your cell phone on top of the car, or the house right next to you. Rare earth elements and rare earth metals. A few of these have become super critically important because they're important for little electronics and to make electronics smaller and cheaper. And I have a sad but interesting photograph to show, or image to show you. Right up until the 1980s, the United States used to be the world's leading producer of rare earth metals. And at that time, nobody cared. It's like, great, we're number one, and they're really not that valuable. All of a sudden, their importance in the global economy skyrockets. And at around the same time, China realizes that they've got the biggest deposits on Earth, and around the same time, we had to shut down the only source in the United States, right here. The Mountain Pass Mine. Imagine what it means that there's one country that has about 90% of the global production of key ingredients for the most profitable sector in the productive economy, electronics. Yeah, exactly, monopoly. As a matter of fact, obviously, you can imagine that a lot of other countries are trying to get in on this game. And China is trying to shoehorn international negotiations to be the leading funders of development of mines in these other countries, so that they can have like a global monopoly on the production of rare earth metals. You should definitely keep your eyes open. If you ever see rare earth elements or rare earth metals in the news, you should read these stories. I have a feeling that in the next decade or two, this is going to be a really explosive conversation. You know, we had to shut down our mine because of environmental concerns, but the United States still has the capacity. The mine is still there and the reserves are still there. So we might open up one of the dirtiest mines in North America because it lets us at least strategically challenge China.
Why so dirty?
I'm not really clear. I don't really. It's not. I think it's particular to the processing of the rare earth ore. Nothing else. Something about separating out the rare earth elements. Okay. Anybody want to talk more strategic metals? Did we distinguish between a reserve and a resource last time? Then we should do number 15, 3 stars, the impact of mines. I'm going to type this up as I say it, so hopefully you can keep up. The general issues in mining. Number one, often massive losses of habitat. Number two, all that stuff you take out of the hole has to go somewhere. So you've got these big piles of dirt and rock called spoils or tailings. Which can become a problem for erosion, sediment pollution, and runoff. And probably the most important is the water pollution. Students, what is acid mine drainage? Yes?
The acids from water and oxidation.
Water's an oxidation, kind of. Anybody else? Yes?
When water leaks out of a mine, it has the minerals from the mine. And since those minerals haven't touched oxygen in their long time for being underground, they oxidize with the air and create acids in the water.
Instead of focusing on individual parts of pollution, I want you to understand one really, really basic problem. Hold on, stay with me. If you are mining like fluffy kittens out of the ground, or like old flip-flops, or like 1960s jazz records, whatever, if you're digging something out of the ground, that dirt hasn't been exposed to oxygen. So buried material oxidizes at the surface. Then you mix it with water. What happens when you mix oxides and water? You get acids. So mines have to keep track of all that water somehow. It's called impoundment. I'm sorry that I typed this slide as I was talking. I plan to reduce other slides coming up. Impoundment is containing surface water, or containing water at the surface, like this. Please look up. You just, at least this way, if it has acids in it, you can contain it in one place. Impoundment is surface containment of water. Mm-hmm.
So for acid mine drainage, what's the drainage part? Is it when you drain the water out?
Yeah, so drainage is water that washes off things. And if it's mine drainage, it'll be acidic. Drainage of mines is acidic. So, we're going to go through a few different kinds of mining. First on the list is placer mining. Stop copying. I know everybody's worried I'm going to move the slide, and I will move the slide, but please look up. Did we talk about placer mines, placer deposits?
Yeah.
We talked about placer deposits, right? One thing you got to remember, and it doesn't say it on the slide, but you have to know this. You extract deposits in a stream bank or along a river where the water slows down, the densest stuff, or where a river used to be. The placer deposit stays. Rivers come and go, but the placer deposit stays once it was made by a river. A lot of placer deposits are no longer near water because climate has changed or the river has moved. Does that make sense? They historically were made by a river, but the river might not be there anymore, even if the river is gone.
At a river and where a river used to be.
Yeah, at a river or where a river used to be, right. I've added this here because I've told you I'm going to be changing the slides. The scale of our problems is growing because mines get larger. So placer mining no exception, used to be really small scale. Now it's become really, 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 really big scale. How many of you have seen an exhibit somewhere, like Barstow or near Lake Tahoe, about how gold mines used to work back in the day, panning for gold and those big wooden troughs? Anybody ever seen those? Those wooden, like... You know, these sort of guys. Gold Rush. Here's all the elements of a placer mine in the smallest possible scale. Watch. This guy is extracting the sediment from the riverbank. This guy is mechanically separating the rock from the gold. Because the gold is really dense, once you get all the stuff of the same size, you pour it down the trough, and the gold settles out of the water first, and the rocks and sand keep tumbling, so you pick up the gold at the beginning of the trough. That's what this guy's doing, picking out the gold. And conceptually, we do the same thing now, except that was really small scale back in the day. Today, this is like a small profile hobbyist operation, but most of the industrial gold comes from very big placer mines. They're finding large deposits of sediment where there is a river or used to be a river. They take that stuff from the side of the river, they separate it mechanically, and they get a whole bunch of dirt left over. People do this in the tundra and in the tropics. You know, one of the sketchiest things in the tropics today, one of the biggest loss of habitat in the tropics today, is illegal mines. You know, most of the tropical rainforests left on Earth are protected, but when you're in the middle of a tropical rainforest, it's not really an environment conducive to law enforcement. You've got some like underfunded government employee hundreds of miles from anything against a band of, let's call them miners in this case, who might have, you know, machetes or machine guns. And what's that law enforcement official going to do? Keep in mind, this is in in many cases in the third world, or at least in the less developed world.
They probably don't even know the ecological harm they're causing.
Yeah, in many cases not. And you know, there's usually somebody along the chain knows that they're breaking the law, but by the time you get down to the illegal mine in the middle of the forest, I mean, it's a totally different conversation. It's a totally different conversation. People talk about this snowball effect that happens in undeveloped tropical forest. First, the miners come in, make the mine, extract the metals. Now that the roads and camps are set up, that becomes really useful for loggers to come in and extract the rare hardwoods. Once you've started to clear up some of the forest, then ranchers come in and farmers come in. And this is the snowball of progress of development in the tropics. All right. Underground mining. Is the classic, like, Zoolander style. When most people think of mining, they're thinking of this, underground mining. You know, where you dig like a tunnel underground. This is a little bit more dirt, a little bit more water pollution than glacier mining. The image you have in your head of like the dudes going down the tunnel with the headlamp and the pickaxes, you know, working in the coal mines, like the donkey and the cart and the shovel and stuff, that is totally gone. There are, I'm sure there's a few like small manual mines left on the planet today, but they don't make any sense. People are so expensive and delicate and inefficient. That's your shovel in a modern mine. That's your donkey and cart. And the complexity of these underground mines has really gone up. We do get coal in underground mines, and we get precious metals in underground mines. But think about it, as the scale starts to go up, all these little tunnels and all these little ramps and managing the water, like you've got groundwater seeping in and rainwater pouring in. You know when the pumps break, there's like underground floods. Can you imagine how creepy that would be? Trying to like outrun, there's like tidal wave of water like in a tunnel, like oh my god, talk about a sinking feeling. This is so dangerous for workers. It's so expensive. The engineering is so complicated. So these mines are becoming very, very rare. Only if there's something really, really valuable in a place that the tunnel is the only option. That's the only times that we do this now. Because at some point, all of this crap is just harder than making a big hole in the ground. So we're now in the era of open pit mining. It's simpler, safer, and often more profitable than tunneling. But it comes with big impacts. It comes with very big impacts. You cannot comprehend numbers this big. I'm not trying to be condescending. I mean, as long as you're human, your brain can't do these numbers. That thing's like 260 stories deep. It's about 3 miles across at the top, the hole. Like the labor alone on this like 28-year-old mine has been something like 67, or somebody gave me all these numbers and I forgot. Like one of my students a couple years ago had a flyer they showed me, their brother works here. And they were like, dude, you gotta check these things out. And I was looking at it, was like $67 billion or some number like that just on labor. So the mining company's like, yo, we've been like working jobs and like giving people stuff to do. But look at the size of that hole. All the dirt that came out, that's all this. This is the quote-unquote spoil bank. A lot of my students are like, oh, acid mine drainage. Come on, obviously you can figure that out. Like, how the hell are you going to trap all the water that comes out of that? What exactly do you have in mind to engineer a simple solution to that volume of erosion? I want to try to put this whole in perspective for you, since our brains can't really keep up with these kind of numbers. Watch this. Watch. You guys see that road right there?
Yeah.
How it like switchbacks down? There's the road. And there's a truck on it. And when I point out that truck, people are like, oh, that's pretty big, because I know what a truck looks like. Give me a minute. Give me a minute. Right. That's not a normal truck. Like when I say truck, you're like, yes, truck, it's Ford Ranger. No. Look, that is a truck. That is a school bus. If you look at that road, you see those little tires? Everybody's like, yeah, you know, the road with like the truck, and there's a truck casting a shadow. There's the truck, there's a Tacoma. Like, look at the tires compared to the Tacoma. That's like a 6-lane highway. Maybe more, right? Like, how many lanes is that actually? Right, exactly. It's a 2-lane road for the truck, for the big truck. But that's pretty much like the 405 and the 10 intersection kind of size road. Like, that's big. I mean, if you like visualize, like, ignore the, okay, watch. Visualize it like that. Okay? So that road, right? Like, oh yeah, that's like the 405. And then go back to this thing and be like, oh dang. Like, I don't know about you. When I scale that road to be the size of like a highway, freeway, my mind starts to stutter a little bit. Like that truck, you know, you have to climb up little stairs to get up to the command center, not steering wheel. Like the drivers, plural, sit in like an air-conditioned like control room to operate the truck.
Oh no, Miles.
Everybody's like, I wonder what size the steering wheel is. Like, I don't think they have a steering wheel. Yeah, like, I don't know what they do. I don't know what they do.
But it doesn't get very good fuel economy.
Right, yeah. I mean, what, 20 gallons a mile or something? And so, like, when we talk about digging those big holes in the ground, and you remember that, like, the crane is a lot bigger than you're, thinking of a crane. This isn't like digging out a trench next to the road at your house. Like, there's the 3-story command tower on the crane. You have to, like, walk upstairs and then go across the deck, and there's, like, a window. And then you walk up the stairs, then you walk up the other stairs, and then you get to the command center. That's, like, on the tower inside the thing. Like, the stuff's really big, okay? So it's a lot of dirt, and it's a lot of water. And, like, when it rains, I wonder if there's going to be any drainage issues. It's not like you can, like, stretch a tarp across the top.
You can't. Wait, that's a little...
No, like, wait. I really want to push you to think about something differently in the future. So try to keep something in mind. Every time I talk to an old person about environmental stuff, they'll talk about waste disposal. Literally, I was on a boat with some dude I'd never met before on Saturday. I'm like, oh yeah, hey Trent, nice to meet you, man. Okay, cool, yeah, right on. Yeah, okay. He's like, works in investment banking. So anyway, I'll teach environmental science. He's like, oh cool, man, yeah, like recycling and stuff. And I'm like, yeah, ish. Because everybody wants to talk about, like, okay, now that I have this thing, what's the right thing to do when it becomes trash? And that's environmentalism. And I'm like, no. Before is really the big question. You remember at the beginning of this unit, I reminded you of that fact from the movie, 70-to-1 ratio? Every trash can that you make at your house required 70 trash cans at extraction and production. Like, I want to make the right point here. Yes, you should recycle. I recycle, you should recycle. Good. Compost too. Why not? But making your trash is a lot worse than what the trash is.
What are we supposed to do? Not buy the stuff?
Right. Yes. Yes. Bravo. That's exactly what I'm talking about. Less stuff.
This is
But
America.
it's going to get made either way.
No, it isn't.
Less demand.
Bro, when it sits on the shelf, it's like, you can make a few less of these, like, baby seal jackets. Nobody's buying them anymore. I mean, esoterically, yeah, that one item you're looking at's already been made and stuff. But as long as we offer an expanding market for the world's goods, there's money to be made along the way. Like, obviously we're going to keep making it. But, like, nobody wants to sell you the stuff that they can't sell you. Like, there's no, like, I don't want to be the guy who sells, like, horse-drawn buggies. People don't buy those anymore. I don't just make them anyway. Look at the water down there. Does that look appetizing? Want to go for a swim?
Yeah.
Immediately break it.
Dude, that's sick.
Strip mining is just the same thing as underground mining, but sideways. Sorry, open pit mining, but sideways. This is the way that we get most of our coal, because coal was made in giant sedimentary layers. So anytime you hear about a strip mine, you can be pretty sure it's hard to reclaim it because we're talking coal, and coal means hydrocarbons, and hydrocarbons mean life dies. So reclamation is really tricky here. Reclamation here is a big, big challenge. About half the coal in the United States.
Sad.
You know, open pit, sideways. So you got your hole, sideways. What?
Instead of going in circles, you're not.
It's just
Like
kind
this.
of like,
You go like this, and instead of going deeper, then you just start to like scoop out sideways.
Oh, so it's not really deep, it's really wide.
nose. Okay, nose good.
I understand the ambiguity. I'm just curious. How many of you visualized what I was saying? Out of curiosity, I'm not. I got this wrong. That's great. I'm just kind of curious. Okay. So again, look. There's your operation. There's your Tacoma. So that Tacoma against that landscape. It's pretty big, right? And mountaintop removal is pretty much the worst thing ever. It's like the worst.
Good thing it's not allowed anymore. Sort of. Right?
The United States really, really, really developed this a couple of presidents ago. And our current president slowed and eventually stopped the approval of new ones. But a lot of these leases have already been okayed and are still doing their thing. Once people get started on a business enterprise, it's pretty hard for the government to stop them. You're forcing people to lose money. That's a tough argument. The government doesn't want to be the money thief. So we don't really do new ones, but so check this out. You got your mountains, and you know that coal is a sedimentary impurity, right? We talked about this, organic impurity in sediment, yes? And so a lot of times, across a whole bunch of mountains, there will just be this like continuous deposit. Anybody ever seen like those little cables you use for cutting cheese? Got like a roller and like a little wire. Imagine that concept. You take the equivalent of like a giant eyeball, attach a very large cable, connect it to a tractor, and you drive it around the mountain to snap off all the trees and vegetation. Then you stick in a lot of dynamite.
That seems so.
Then you walk safely away. And you send some gullible idiot to light the fuse. And it goes pop. And you've got mountains of powder that you can just throw into the neighboring valleys. What used to be down there?
Streams.
Rivers Frozen watersheds, that's right. So there used to be this thing called the Clean Water Act about like protecting surface water. And we had this president once that was like, oh, well, that doesn't apply, obviously, because, you know, there's no more river there, so it's not on the map. So we, the government, we can't regulate where there isn't a river anymore. And all the natives are like, and literally, like, right after his presidency, the Supreme Court's like, no, that doesn't make any sense. And so we like, don't really, there's not a lot of new mountaintop removal sites going now. It's become a whole lot harder to do this.
Is there a video of the mountain getting blown up?
I'm sure there are, but when I made this slideshow, this was a really touchy subject, and it was very difficult to get coverage of this. You know, a lot of these sites are like $200 billion budgets. This is like gigantic numbers. So people will literally buy the skyline of property around it to prevent line of sight. Yeah?
What's the point of removing the vegetation from the combination of blow up?
Something about making it easier to structure the fill. Because what you want to get is this, a parking lot with piles of coal in it. Like this. Look up. This would be a mountaintop removal. But I just put this one first because it really shows the pile of coal. Remember that ores are often colored like the rock. So in this one it's really visible, but that's a really small project. This one's tiny. Like across the landscape. Multiple mountains, just to leave these. That's what a mountain used to be.
That's just like underneath the top of the mountain.
That's right, yeah, exactly. So all of this, it's all vegetated there. You see that? That's all the fill. That used to be a river valley. They took the top of the mountain, pushed it over here. You can see that's all got ledges, right? Everybody can see that's all man-made? And there's your settling ponds to catch all the runoff. This is like miles of mining. They have to build dams to stop rivers of impoundment. Occasionally those dams break, by the way. I really want to remind you that we have the luxury of the problem of what to do with our trash, but that is a rich man's problem. Like, what do I do with my trash? Like, lucky you. And before we start talking about waste and trash, I have one little part left in number 15. You remember the ore I showed you earlier in the... Sorry, everybody, I just got distracted by something. Oh no, James. Someone took your phone. Oh. That's the worst. I'll have to like launch an investigation and find the offender. Maybe it'll show up back on the solar house so we can continue with class. Let's hope. Oh, bro, I knew it was you. This is ore of copper. How am I going to get the copper out of the rock?
With the pickaxe.
You see, we've been talking about how nasty it is to make holes in the ground and get stuff out. Remember, the stuff that comes out isn't ready to use yet. We still have to refine the resource. So please look up. We can use what's called smelting. You should know these. I wait all year long to use this term. Smelting is, quote unquote, cooking the rocks. See, you're not hip to the crack terminology. Yeah, we laugh at Baltimore. But you do literally cook rocks, like actual rocks, and you get really, really hot. And this is super energy intensive and releases a lot of SOx. Yeah, energy content and sulfur oxides.
How do you do that with coal?
Well,
Because doesn't it burn?
you can't do this with coal, but you consume coal to do this. Yeah.
Is this just for extracting ore or like other?
Smelting is almost all for metals. Because you remember I told you that metals have a lower melting temperature than rock, right? So you just heat up all the rocks and the metal pours out and the rocks are just red hot rocks. And you know, we're talking about large scale heating. So, you know, like if you walk into a giant jacuzzi that's using up a lot of energy, this is like a lot more heat. Number two, check this out. This is, you can make a heap and then you use a shower of acids to dissolve the rocks,
Nice.
and then the metals leach out. Heap, leach, extraction. Acids to melt the rock. What could possibly go wrong?
I wonder if acids
Lemon.
Finally, there's this thing called a mercury amalgamation. Please look up. This is illegal. That's why there's an asterisk right there. It's illegal. You're not allowed to do this. But you know, if you're running a gold mine that's illegal, in the middle of the tropical rainforest where nobody can hear you scream, mercury is a really cheap way to refine gold ore. How many of you know that you're not supposed to eat the trout on Paradise Road by Red Rock and like?
Oh yeah.
If you go in our backcountry, you're not supposed to eat the trout. Anybody know why? They're full of mercury. You know why they're full of mercury?
Mine.
Because there used to be gold mines back in the day on the backside here, because you know, mountains of metals. And in our mountains, they would take the gold ore, and check this out. You grind it up, pour in a bunch of mercury, and when you heat it up, mercury and gold stick together, and that makes a really heavy amalgam. You know what amalgam is? It's a mix of two metals. It's like blended together, like two colors of Play-Doh. So you get gold and mercury to settle out, and then you heat it up and like use acids or some nitric acid, I believe. Anyway, the details are kind of crappy. Uses a lot of energy, uses mercury, uses acids, and produces a lot of nitric acid waste. Usually for illegal gold mines. This is one of the reasons that people get so uppity about the source of their gold. First and second. Yeah.
Yeah, I heard like near Red Rock and stuff back there's like a lot of naturally occurring mercury, like in mercury mines. There's like mercury mines, like old ones.
I know there are gold mines, and they use mercury there. Maybe they got the mercury also in that area.
Yeah.
Yeah.
So it's legal
That's why.
because they can't control the mercury, or is it the acids?
I guess because of its general impact, but the primary source of mercury pollution for people in South America is Brazilian illegal gold mines.
So you can't control the mercury.
Right, there's a lot of mercury. Like the Amazon River has exceptionally high levels of mercury. When I went there, I ate this fish called arapaima, which is one of the largest tooth fish in the world. And everybody told me, like, oh, you know, it's kind of a delicacy. You should have it, but only once. Because I guess the mercury poisoning is, it's no joke, like very, very, very severe. That process of heating it and binding it with acids and stuff makes it more likely to methylate. So, yeah.
I believe you can farm Arapidon now.
Arapidon? Cool. I know you can raise them in aquariums. I've had one as a pet. They're very similar to the arowana. Okay, so I'm done.
It's okay, Jose. You can have more. Be careful where it comes.
What day can we come into the storehouse stuff I want to today?
Remember, your re-submissions are due today and tomorrow at lunch. There will not be other opportunities today and tomorrow at lunch. Yeah. Or the plan, either of those.
Sure.